Okay, welcome back, everyone. This week, so far, hopefully you have the big picture about learning and the connection of that with math, and therefore the connection of that with how we implement things in software. Moreover, that software for machine learning is all about performance. You need to forget several things that were important or are important for other projects. All the object-oriented paradigm is like low performance. But you need to forget that only for the inside of the box. Like the example that you're reviewing right now, the source code that I shared with you. Hopefully you are almost done with the homework. And one of my goals is that you review the source code and it's like, we're using only arrays, not linked lists, not collection classes in Java. We just go down to the basics because we want performance. We don't care about even the use of resources. You notice using more memory is, we don't care, but the speed is the important part. You're almost programming in an imperative way, procedural programming more than object-oriented, because that one gives us better performance. Now, however, and this is what I want to move today, it's like there is some kind of software engineering that we are going to connect here, and there are going to be some point in which classes and all the things that we know from design are going to go back to be important. They are not important for the inside of the box, but they are important for the outside of the box. And let's talk about the outside of the box. Let's talk about, okay, what happens if I do not want to develop the library? I do not want to go down to create my own class neural network or others, but I just want to use them. So let's go back to this idea, like, forget about implementing a linked list or a stack or a queue, because there is already a library collection that I can use. So let's go back to the idea that if I want to create a neural net or any other machine learning thing, probably there is a library, because probably someone else already implement the same things that we're reviewing right now from scratch, right? This kind of makes sense. We have libraries for everything. Machine learning is not deception. Libraries. We're going to be reviewing some of them, a collection of them. But step number one, something that I think could be interesting for you to review, which are the libraries in machine learning that you should know? At least be aware that they exist. Maybe not because you are going to be expert using them. Hopefully you are going to be expert using a couple of them, but at least knowing the name in the same way that you connect the idea of Visual Studio, Xcode, Eclipse, or things like that with some particular things, because you have worked with them. Thinking about machine learning and things about libraries. Again, we're not going to review here all of them, but I am sharing with you this paper. It's on Canvas. I put the link here. It's literally a survey, 2019, about machine learning libraries. It is not about a particular language. It's just about, these are the libraries that we use today. These are the libraries that, according with the survey, the authors result to be important or interesting. You can review the paper. They are going to explain to you how the survey was done, why they consider important some of them, not others. It's just information. It's not part of the things that I am going to evaluate in your exam or something like that. I am just sharing with you the reference because I am going to start with this picture, and the picture comes from the paper. And it's kind of the summary of the libraries in machine learning that those authors consider people, engineers, know, or students should know. Tell me, any of the names there sound familiar? I am pretty sure that doesn't matter your experience, Doesn't matter how connected you are with machine learning, but just browsing online or reading some sources, several of these names are like, oh, I have listened that thing. You are going to notice that some of them are even connected or suggesting a particular language. Some of you asked me about, Professor, why are we working with Python? Don't worry, I'm going to answer that. But here are mentioned some libraries connected with that particular language, right? And others, some of them are connected with C. One of them in particular that I put in a circle at the top is connected with Java. Java, yeah. When you read these symbols for Java, right? I am going to start with that one. That is the one that I want to cover today, probably this week. A library for deep learning. Deep learning, remember, neural networks, not only, but a big representation of deep learning is with the neural networks. We have been working with neural networks. Let's work with a library that is supposed to help me with neural networks. And let's see if using that library, we can do something better than the things that we have done before, and how that library works, and how that library is connected with the things that you know from software engineering. In fact, I already showed you some source code from that library, if you remember one example that we reviewed with the builder factor. So we're going to work with that one. Not the only one. We're going to work with more libraries from here, not all of them. But if you want to know at least a summary of what they are and the use that they have, the paper is a starting point. I share with you, up to you if you want to read. Good? Now, deep learning for Java. Professor, why did you choose that library to start? Well, number one, the people is using them. If you work with machine learning, and in particular, you're working with Java, that library is one library that you are going to use. Now, but in Java, not really. That library have a lot of wrappers. Even though you are using Java, you are going to notice several parts of the library connect with Python, Scala, and even C++. You are working with Java, yeah, but the library itself is not limited to the Java virtual machine. Let me be clear. Usually, your knowledge of Java is, I am going to create my program here. My program .class. And this program is going to be running in my computer, but it's going to be running over the Java virtual machine. And I am kind of enclosed here because, you know, it's Java and Java running the Java virtual machine. That is not true. That is not true. Why? Because for any Java application, simple, trivial application, yeah, this is the way that we work. But do you remember that we can have access to the full memory? Do you remember some programming language that you review that if we use something call it pointers, not in Java because they do not exist, but in other languages, pointers give you access to any place in the memory. One of those languages, C++, right? What if here in your program, in a library, whatever, you put in a wrap, in a class file. C++ code. This C++ code can allow you to use pointers. And this C++ code can give you access to anything, even outside of the Java virtual machine. Makes sense? That can be done. Yes, of course, that can be done. You can put C++ source code inside of a Java library, inside of any Java program. It is important to know how. We could review it, but right now, the most important thing that I want you to be aware is a language. The things that you create, your dot classes that originally run here, they can include code for and from other languages. And if you put C++, automatically, you are giving me access to anything, because C++ can be connected even with assembler. Why that is important? Because when you think about a Java library, usually you think that that library is going to be limited to a low speed because the Java virtual machine. Moreover, you can think that that library is not going to be good enough like others for accessing particular resources. It's not going to be with a good performance. It's not going to allow me to work with things that only exist in other languages or other architectures or other things that are not Java related. You can put all of that inside of Java, use in a click. These libraries, among several other things, support for several languages. We're going to check what that means. But the most important thing, support for the CPU, obviously, but also support GPUs. NVIDIA, CUDA, OpenCL. Even you can connect with a cluster using Apache Spark or other platforms. The language is not a limitation, and the library is good enough to have all of those fancy things implemented. And you continue working in Java. You do not worry about the inside of the box, but the box, the inside, is good enough to offer you several things. Python. It's not like you're going to program here with Python inside of your Java class. Forget about that. The point is, you can use Python to create a model, like to training the net that I showed you before. You can save that model, and Python is going to give you a file. But this library helps you to read that file and put that file in a data structure inside of Java. That is the power. That is the connection between the languages, the models. Makes sense? Okay, it's commercial. Several languages involved, resources involved. Moreover, the power of the library is that allow you to create neural networks. Now, the one that we did is a trivial, simple, naive neural network. Inputs, outputs, and some nodes in the middle. That is not real. That is a hello world program. Something that probably you read, and we're going to work a little bit, is, did you know that there are all these different categories of neural networks? That when we talk about neural network, it's not that example that you are reviewing right now from scratch, or that I show you about the XOR operator. There are, and in particular, we need to talk about at least these ones. The convolution. Good? Anyway, the point is, it's a library and offer me a lot of possibilities in resources and in things that I can do. It could be a good point to take a look. Now, in particular, the library is good for image recognition. Several things that I mentioned there, but in particular, I highlight the idea of image recognition. And probably we need to do an example in that particular category because it's one of the categories in which this is supposed to work. Now, Good for image recognition, the neural network. And this library allows us to create neural networks. More complex ones than the ones that you're reviewing. Again, the ones that you review for the XOR is very basic. Let's create a network for image recognition using the library, not from scratch. Makes sense? Now, okay, that is a very good idea, but let's start with the hello world. Let's start from the beginning. Deep learning for Java. The first thing that you need to know is this one is a platform. What is a platform? Libraries plus frameworks. Software design. Do you remember the difference between a library and a framework? They are not the same, right? One difference. Yes. And this one is a platform. Quick definition, a platform offers both framework and libraries. You can have inversion of control for some things, but you can have libraries for other things. You are going to notice what we're going to do. Library, create an object and call the object. Framework, create an object and pass the control to the object, and the object is the one that is going to work, and I am going to be notified about the results. This platform, that is the name for this. You're going to find, oh, it's a library. That is true. You're going to find it's a framework. That is true. The reality is both. Doesn't matter. This guy have several different sub packages or sub modules or components or elements inside. When you think about deep learning for Java, we're talking about a lot of things. It's not just one library, one file, one jar. It's something huge. And that something huge is going to offer, among other things, the following. I put in the slide several things, just to give you an idea of how big this is. But in particular, the ones that I put in yellow are the ones that we are going to use in the next example. So just for you to remember what I am talking about. Number one, there is something, a module, that is called datavec. Something that the library is going to give you is elements, classes, several of them, to work with inputs. What are inputs? Do you remember these tables that we use for the XOR operator? For images are going to be all these pixels. It's an array, a 3D array. This component of the library is going to allow you to work with input data from reading to store the data in the memory. That is the trick. It's so easy. No, it's not so easy. It's complex. And that is the reason, because we have a sub library or sub model that is going to deal only with that part, the input. You're going to read that name. And every time that you saw datavec, the library, remember, that is there because it's helping me with the inputs, complex inputs. You have other things that is called ND. For you. If you're familiar with Python, maybe you know this name. If you're not, it's not important, don't worry. What are num, ND4J, or the equivalent in Python, operations to work with matrix? More than that, but as a summary. Those libraries in Python or the equivalent, the wrapper in Java, are going to give you methods that correspond to operations that you do with data. In particular, data that is stored in tensors, one-dimensional vectors or two-dimensional arrays, matrix. Operations. We need operations to work with the neural network. The neural network, what you are reviewing right now is basically a bunch of equations that you are running again and again. And those equations, the way that you run it is multiplication of matrix or addition of matrix, among other things. Everything is there in a library. Obviously, you can work with Python scripts and you can work with Tensor like you do with this. Let's review the basics and then we can move to the specialization things. Other things that you need here, I just mentioned that you can create several different flavors of neural networks. I just mentioned that you can connect with C, C++ because you're using pointers. There is a particular library, libnd4j, that is your friend if you want to connect with C++ libraries, other libraries that already exist in a different language, the wrapper. If you want to work with cluster, distributed computing to calculate your network, yeah, you can connect with the Spark platform in Apache because there is a library here that allows you to do that. But again, those are the specialization things. The things that we cannot run out is this one, the operations, and this one, the data for inputs. And obviously, here inside, we're going to have the core of the deep learning for J. And this core is the one that we're going to use to create the neural networks. The libraries at the core. With that, we can start programming. Now, the first thing that you need for the programs that we want to create, you need those three components. You're going to need this, and something like this. Question: if they are packages, modules in Java, what do you think they are going to be physically? How do you put those libraries in a project? Yes. Can we agree that what you're going to have, what deep learning for J is a bunch of packages, a bunch of jar files, and obviously the jar files have inside or can have inside more jar files, right? At least you're going to need 3 jar files in your project. Those 3 correspond to those three elements, among others. But my point is, the first thing that you're going to do, the first thing that I am going to ask you, if you want to start working with this, is you're going to create a project. And maybe for the first time, I am asking you to create a project in which you need something in your project, a module, a library, a jar file that is not by default there, but you need to import, to include in your project. Make sense? So step number 1, in order to create something like that one, that could be a diagram like this one. We checked this picture before. In order to have that red box there, in order to use this class multi-layer network that we talked about before, my point is that is going to be one class that is going to be here in this jar. And this program, if I ask you to do it, the first thing that you need to do in order for this to run, even if I share with you the source code, is to have those jar files, those libraries in your project. Make sense? What if I just put the class inside of my project? It's not going to work because that class is using other classes here. Moreover, this one is using other classes here, or this one is using classes here, or in a different package. The fact that you're using only one, when you think about the inside of the box, is that one is connected with a bunch of things that maybe you are not seeing at the first time, but it's there. You need to have all the jars. One is missing, your program do not compile. Makes sense, right? It's like obvious. Okay. So I do not want to start with this one. I want you to start with this one. Why this one? Because you already implement this from scratch, right? Makes sense that we implement this with the library, and then we go back to implement the other one, a more interesting one, with the same library. So let's start with a hello world with the library, and you can compare with from scratch. Because you almost know this every single detail. We implemented everything, line by line. The library. You're going to need a lot of things that for solving this problem, we are not going to need, but still, you need to put them there. All these jars, even though we're going to use basically one class from each one. Jars files, going with the names. Option number one, you can install in your project, you can connect your project with the Deep Learning 4J package. You can put all the Deep Learning 4J libraries in your project. Or you can just put these 3 jars. It doesn't matter what you do, but these are the 3 jars that we're going to be using. We're working with these 3 guys, period. If you want to copy your program to your friend and you want your friend to be able to run your program, those are the 3 jars that he or she needs besides your own class files, period. Datavec, the inputs. Deep Learning 4J, the core, the neural network implementation. ND4J, matrix operations. Oh, 3 jars, 3 things, 3 core elements. Good. Question. Do we know how to include the full platform or a platform, a framework, a library like Deep Learning 4J in your project? Or do you know how to include these 3 jars in your project?
We can do it manually or via mail.
Do we know what is or an equivalent thing? Everyone. I do not need to tell you how to put libraries in your projects. Okay. If someone do not want to talk, use contact the TA. She can help you with libraries. My assumption from this point and moving forward is that you can put Deep Learning 4J inside of your project, or you can copy these packages, these 3 jars in your project. I don't care if you know this or you just put the jars, but you can have it, and therefore you can create projects that use classes that are inside of those jars. I am correct? Okay, I am going to trust you. Good. So you have those 3, or you have the full collection of them. If by any chance what I am telling you do not make sense about this, or you need to use another one, or you just need to include the jars, this could be a good point to start learning about how to install Deep Learning 4J or a library inside of your project. If you already know that, or the jars or whatever, you do not need to review this. But this is just my help if you need that help. But again, you can contact the TA, or you can read this. Whatever you do, but be sure that now you can include libraries. This is the first one, but I am going to ask you to include libraries several times in the future of this class. So that is important. Good? Okay. Now, assuming that you have the libraries, we can start programming. And to start programming, let's see. Number 1, can you agree with me that the first thing that we need in order to do a program like the one that you are doing with the XOR operator is the data? Do you remember that in the name of the program that you're reviewing right now, the first 2 lines are the lines that load the data? Do you remember what do you have there? What is the representation of your data? Do you remember that you have this one array for the input that is bidimensional, 4 rows, 2 columns? And do you remember that you have another array for the output that is 1 column, 4 rows? Do you remember that from scratch? Okay, you did it from scratch. Therefore, what you used were arrays. You know what is the main problem that you have in that solution? Do you know what happened if I asked you just to scale the program that I shared with you for the XOR, and I asked you to make that work for pictures? What is going to happen? That the pictures, each input is a pixel. And how many pixels in an image? A lot. Your arrays are going to be huge. Professor, it's not a problem. The only thing that I need to do is to increase the index. Instead of an array of 2 times 4, I can create an array of 2,000, 4,000, hundreds, or whatever. In the abstract level, that is true. What about the implementation? Can you create in a Java program an array that is hundreds or thousands of values? You can. Java is going to allow you, but there is going to be a problem. What?
If memory will be full for.
We are going to have a problem in the variable with the memory. How many memory can you use in a Java program? How many memory can you use in an array that you create in Java in the way that we did it in that program that you are reviewing? You have a limit, right? I mean, if you have your computer and your computer has this amount of memory, a Java program can use all the memory in your computer. How many memory can a Java program use? Only the one that is provided by the Java virtual machine. If you want to create an array that is huge, and you are thinking that the limit for that array is going to be the full memory of your computer, that is not true. Your computer can have a lot of memory, but the Java virtual machine is going to allow you to use. That is the rule. That is Java. Remember, Java, the virtual machine, the nanny, so you do not make mistakes. But now you want to use more memory, not for the project that you are doing, but again, for a real project, for using pictures or other things that is a lot of data. The first thing that you need to do is move out from the Java virtual machine. The first thing that you need to do is put your data here, outside. Two options. Option number one, you can learn how to include C++ code in your program. And then using C++, you can create pointers, and the pointers are going to be outside of the virtual machine. From scratch, that is your next step. That is the thing that you should do to improve the program that I shared with you. A wrapper for C++, and using that wrapper, create arrays. Okay, now, let's use a library. The library that we have here for the input is going to allow you to create your arrays, and it's going to put those arrays outside of the virtual machine. Why? Because that library is going to work with other things besides the Java native source type. Put data outside of the virtual machine, number one. Number two, when you create your data, when you create an array outside of the virtual machine, you have a problem. Inside of the virtual machine, any array that you create, like the ones that you did, have default values, right? All the values in the arrays that you create by default are 0. Any integer by default is 0. What happened with the things that you put outside of the virtual machine? What happened when you work with C++ to create arrays? Do you remember the problem with the garbage? But I am using Java. You are using Java, but you just open the door to go outside. And when you go outside, the rules are, you are creating your array, but it is full of garbage. The first thing that you want to do is to clean that garbage, initialize the values. This library, the first one that we're going to use for the inputs, go outside of the virtual machine and initialize values. Two things that we need, the library is going to give us that. Clear. The only reason for use the library is because we're planning to use a big amount of data, and Java is not good enough for that. We need to move to C++, but we do not have time. We do not want to put C++ code inside. We just want to use a library that does that for us. Okay, that is the full theoretical background. Show me the source code, please. Source code. That was our input, right? And in your program, this one is one line, one array with the data. Using the libraries. Do we understand the source code? Let's see. We're doing an object. Input. Okay, input is going to be an object. That object is going to encapsulate this thing. We need an object for this. Okay, what is the class for the object? Huh? What are the meaning of those letters? That class is going to be, or is going to be somehow connected with these friend libraries, n-dimensional. Array. We're creating an array with multiple dimensions, ND, and in particular for input data. Oh, okay, one class for that guy, whatever. Array. Multiple dimension, ND, for the input data. Okay. The name of the object, input. And what are we going to do to create that guy? Can you help me? DL4J. What is that one? It's an object, it's a class, it's a method, it's a variable. DL4J. Uppercase the first letter. It's a class. It's a class that this guy is going to use from here. It's an operation, the thing that we're going to do. We have a variable, an object. We need an operation from a class that is inside of a package. Help me, zeros. It's a method, yes or no? Static or no? How do you know that it's static? We have a static method zeros, and that static method zeros receive two parameters. Can you imagine what are the two parameters? 4 and 2 suggest you something. Okay, we have a class, and that class is for n-dimensional arrays, and we're asking to create a new one from a factory. And the creation occurs when I call a factory method called zeros, because it's going to give me something, the product, but that product is going to be initialized with 0 values. Remember, garbage, zeros. And the size for that something is given by the parameters, and the parameters in this case is 4 and 2. One line, and you have an array, 4 times 2, outside of the virtual machine, with zeros in all the elements. And the only thing that you need to remember, and your IDE is going to help you, is the data type for the object, and the name of the factory class with the name of the factory method. Good, right? Okay, what is the next thing that we want to do with that object, in which now we have this array with these 4 times 2 spaces, and all of them are zeros. We do not need the zeros, right? We need the data. Can you help me to understand this method, put scalar, that seems to be a method that is not static inside of the class int array? It's a method from the class, right? We're calling with the object. Put scalar. Can you agree with me that what we want to put here, these numbers, are scalar? They are not arrays. They are just a value. A fancy name for that. Put a value. Where? In this table. What parameters do we need? 2 parameters. The value and the position in which I want to put the value. When you work with arrays, maybe you work with, this in the position, this equal to this, right? The position according with the array. But this one is an object, and we're calling a method. And we need to pass as a parameter this one, and this one. 3 values as a parameter. One option could be to have put scalar, parentheses, number, comma, number, comma. But then if you have more than 2 dimensions, it's going to be number, comma, number, comma, number, comma, number, comma, 4, 5, 6, 7, a lot of values, right? So engineering. 2 parameters. The value, always, one of them. The position, the coordinates, 0, 0, 0, 1, 2, 3, whatever. The coordinates, instead of 2 numbers or separate numbers, put the numbers together. Put the numbers together, 2 options. Number 1, you can have an object, coordinates. But you really do not need an object because you are not going to have methods. You are not going to play with coordinates. It's not for geometry. But you can have is an array with those numbers. Can we understand what is this, and so on? An array initialized with a particular coordinate. Do we understand 3, 1? 3, 1, the last value. And what I want to put there, my new array outside of the virtual machine, the initialization of the values, done. I am giving you this source code that is kind of really too long, used for that. You connect the dots. And what you can do later, what you're going to do later is all this is going to become just a for loop reading for a file. Right? Clear, input. Output. The other thing that we need in the memory is to load the other array. That one looks familiar. Can I do this? Can I have an array with only 1 dimension, with only 1 element? Yes, I can. Why I am using an array? Just to keep the parameters same type, consistent. Position 0, 1, 2, 3, value 0, 1, 1, 0. Same data type and same method. Same process. Very clear, right? Very simple. Okay, this replaces your 2 arrays in the program that you are reviewing. Now, okay, that is fine, kind of easy. We finally use some classes from the library. Question. In some point, we're going to need these 2 objects like together. Like these are my inputs and these are my outputs. There is a name for these 2 together. Input plus output, expected output. What is the fancy name for the inputs and the labels for those inputs? Inputs and expected output. Maybe is the thing that you call a data set. What you need to use to train your neural net is a data set. What is a data set? The collection of input with the labeled data. We're talking about classification, right? We're talking about supervised learning. Your data set is going to have these two. Those two, you are going to need them to train the net. It could be a good idea to do something like this. Do we understand what I am doing? You are creating a new object. Your new object is from a class data set that is going to be there. And that new object is basically going to have the input and output that I just created before as an object. Can we remember? Input, the known output, and the data set? The three things that we have so far? Easy, okay, no problem. Next. With this, we have the data. One thing is to load the data. Second thing, we need to create the neural net. How to create the neural net is something that you did in the constructor of the class that you're reviewing. Do you remember what is in the constructor? You have a full constructor with establishing parameters, creating things, the array, the size of the W's and the bias and so on. Here, yeah.
When we define the data set, we put an output out of different dimensions.
No problem. We are just connecting to objects. Whatever is in the object is not a problem, not yet. Depending on what we're doing with the data set, we need to follow some rules for the dimensions. But just for the object, we can do what I showed you, that's it. Could be problems later if we use a data set in which we are expecting some kind of dimension things, because remember, we're going to do operation with metrics. So the point of the dimension is going to become a conflict if we try to, I don't know, multiplication with things that do not match. But so far, you can create whatever, right? It's possible. Neural net, your constructor in the software that you did, your full constructor can be replaced by this. And now we can review the details here. What we are doing, something that we already told before is we're doing two things. The most important one is create this object, the one that we use to represent our network. But this thing needs to be configured. You need a configuration. The configuration, because that network is going to have a particular number of nodes, connections, the equations that you're going to use, values that you're going to initialize. There is a lot of things that you need to initialize the object, to create the object. That configuration could be just parameters here. Very bad idea. There are a lot of parameters. The solution that you know exists when you want to pass several parameters to a particular object is forget about the parameters, pass or use a builder. The builder, the pattern, is all about put your parameters inside of one thing that you call the product that that builder is going to create, and that one is going to be your parameter. Only one thing that encapsulates all the information that you want to pass. This is what I need, and all of this is just creating an object configuration that have the information that this object needs to create the net. So anything is happening there, just gathering information. Information. You can put the information in this another object. And what you can use is a lot of setters or the constructor or whatever. But the fancy thing that you can do with the builder is this string in which you connect with the dot, calling several methods. And that helps us with the documentation. Because instead of adding a comment in which I told you the first parameter is this, the second parameter is this, the third parameter is this, and so on, you just call particular methods that have one or a couple of parameters that are easy to follow. For instance, this one. Okay, let's start. We want to configure a neural network. I am going to create an object. That object is from a particular class, neural net configuration. Okay, whatever. Neural net configuration builder. Tell me, that builder, what it is? Variable, method, class. Parentheses, right? Method. But why the B is uppercase? Constructor for the builder. Okay, what is going to give me? An object. The object that is going to have the weight init method and all the other methods that I am going to create here is a calling to a method in a class that is going to return to me an object that I can use to call the next method, that is going to return to me an object that I can use to call the next method, and so on. Every single method listed here, starting with the builder, is going to return an object, and that is going to make the next call possible. Can you help me with the first red thing, the first parameter? Init.uniform. Do you remember what is the meaning of that in the things that you're reviewing? Init what? The W's, the weights, uniform. Initial value for all the W's, the same. For this case, zeros. List. List is for the beginning of the layers. Did you notice? List. Layers. You're going to create a neural network. You remember, the first thing that I am expecting, or this is going to expect, is something about the initialization of the W's. The next thing that is to expect is a list of your layers. How many layers do you have? Can we create several? Yes, as many as you want. But the example that you're doing right now, the example that you have today is 2 layers. 2 layers? Yeah. Remember the nodes? You have nodes in the middle and you have nodes at the end. What happened with the inputs? The inputs are not nodes, they are just inputs. This is the picture that you have. Layer 0 is the one in the middle. Layer 1 is the one at the end. And did you notice the parameter, the class that you are using to build that layer? What are you passing as a parameter for the layer? Did you notice the classes, output layer and dense layer? There is any reason because we do not have used a class layer, and there is any reason because we need to specify, separate, like, okay, this is for the input and this is not the output? Did you remember why we separate the output from the others? If you remember the math, the partial derivatives were different to calculate the outputs that from calculate the middle layers. That is the reason because we have these 2 classes. Because one class is going to have some particular equation and the other is going to have a different equation. Part of your homework, I asked you to transform some lines of code from the program to the equations. And the thing that I want you to notice is these 2 are different. And that is the reason because you have 2 classes. You do not need to explain the developer that the equations are different. It's just the layers are different, use different classes. And if you're thinking about a common parent layer and 2 childs, output and dense, you are right. They have a common parent, but 2 childs. Output layer, that is easy one. A dense layer. Professor, why that one is not used inner layer or middle layer or other thing? What is that word dense? I mean, fully connected. Fully connected. All the layers in the middle are fully connected? No. Do we always use dense layer there? No. There are other kind of layers. We're going to review it. But a very common one to be in the middle is a fully connected layer with the previous one. In your example, if you remember the middle layer, is fully connected. all the inputs to all the nodes, two input, all the nodes have those two, is a dense layer in the middle. And you have the output. Good. Did you notice the second parameter in both cases? It's a constant, right? It's a constant, but in some point in the library, there is an if condition, activation equal to activation dot sigmod, that is a number. You are going to call the sigmod method. You have the sigmod method in your program, right? The library have the method also. And we already agreed that you can use diverse activation functions. You do not need to implement the method. Use the constant that represents the method that is already there in the library. One important thing, it is not mandatory to use the same activation method, the same activation function in all your nodes. However, is the common practice that all the nodes in one layer use the same activation function. So sigmod here, and in the output, you can put a different thing. But for our example, the one that you're reviewing, we use sigmod for everything. So this is the representation of using sigmod for everything. For image recognition, this is a very bad decision. And I am going to ask you later to change this to different options. And you're going to notice what is the result of the learning. But now, instead of asking you to implement the function, is used, I am going to ask you to change this constant that represents the implementation of the function that I show you, the plot. That's it. Can you help me with the numbers? In, 2, out, 3, in, 3, out, 1. What is it?
Yes, there is 2 inputs and 3 outputs. And the output layer has 3 inputs and only 1 output.
Do you remember the picture, right? The middle layer, 2 input, dense layer. So these 2 to all the nodes. 3 outputs. The last one, if the other one have 3 outputs, I am going to have 3 inputs. I want to connect everything, but I am going to have only 1 output and therefore 1 node. Each node is 1 output, remember? Input is one thing. I can have several inputs to 1 node, but the output, each node is 1 output. If I ask for 2 outputs in the network, that means 2 nodes in the last layer, in the output layer. At the end, build for the list of layers and build for everything. You need to memorize some of the methods, but the most important thing is to understand the parameters. And I am sure that now you know exactly what is the meaning of those parameters because you are implementing this from scratch. Moreover, we review the theoretical background. It's used a fancy way as a builder to put the data that you understand in order to create a neural network. But again, all this is used the data structure. All this is all the elements connected, but this is doing nothing. What is our next step? We have the data here. We have a neural net with those characteristics here. Next. Yeah.
Is there a place where we say how many nodes are in a layer?
How many nodes in what?
In a layer, in a given layer, how many nodes are there?
The number of outputs. So each output is going to be a node.
Oh,
So the thing that we put there in the end out is going to be the number of nodes. Good. So the network, done. The data, done. Next step, if you remember, training. And training is a fancy name for forward propagation, backward propagation, again and again and again. Okay, training. Do we need to implement the methods backward, forward, and etc.? Not really. That is the power of the library. Training. Before starting the training, let me show you some fancy methods. I need to review to be sure that I have this neural net, that this is my data structure. Init, call the constructor. Something that we didn't specify before, the learning rate, 0.7, the same number that I used with your example. Network is this object that have all the configuration that we created before, calling the init, calling the learning rate, you configure things. Something that you can do, a method that you have in the object network is this method summary. Summary is a method that is going to return a string, and therefore you can print the string, and it's going to show you something like this that is supposed to be the equivalent to this picture. It's the information for you to be sure that what you create is what you want. This is the output of this print here. Do we understand this information? Do we agree that this information is what we have here, what we want? 2 layers, we agree? One is dense, and the other is output. 1, 2. The one that is dense, 2 input, 3 outputs. 2 inputs, 3 outputs. 2 inputs per node because it's dense, and 1 output per node. In total, 3 nodes. Output layer, 3 inputs, 1 output, therefore 1 node. What? W's, 2, 3. 2 W's times 3 nodes, an array of 2 rows, 3 columns for the W's here. That is what I need to calculate this layer. 2 W's in 3 nodes, 3 W's in 1 node. How many W's do we need to check the dimensions? Bias, 1 in 3 nodes, 1 bias per node, remember? Bias, 1, 1, 1 bias, 1 node. These are going to be my matrix. Okay, this makes sense with this. Good. Total parameters that we can train 13. Why? 9 per 4. 9? 3 times 2, 6 plus 3. 3 times 1 plus 1. These are the parameters that I'm going to train. Yes, the W, but also the bias. Remember that the bias is something that we also calculate in every backpropagation, and the W is something that we calculate. So these are the parameters that we're going to be calculating for this neural network. It's a very simple one, but this use hello world. This looks to be, yes, what I need. Good. Okay, now training. Training. Can you explain me what I am doing there? Probably my first question is, why that 10,000 in the for loop? Do you remember the 10,000 that you have in the program that you're reviewing? Why 10,000? It's a number, a big number. Why I put 10,000 here? Just to match with the example that you have. I mean, just try with less or more. Is the number of times that you want to do the training, the number of times that you want to do forward propagation, back propagation, forward propagation, back propagation. And remember, each of those 10,000 times is going to run with the 4 rows that you have, with the input. Remember, in the code that you're reviewing is 10,000 for 1. Remember. So it's 10,000 with all the data in the data set. Only one line inside of the for loop. My network dot train fit. Why not train the name of the method? The author of the library one fit is a good name, fit, and the parameter is the data set. I am sure that you can remember where this code is in the source code that you're reviewing. And it's a little bit longer. This is the black box running, doing the learning part. You can forget about linear algebra, the derivatives, and so on is inside of the method feed. The running of this method is the one that is going to use a lot of time and memory and resources in your computer. The running of this method is the one that is going to connect with the GPUs, CPUs, and so on if you have support for that. But the only thing that you're going to do is to call the method. Done. And for this example, it's very simple. It's going to run in a couple of seconds, and you're going to have similar results to the one that you have with the source code that I gave you. Now, in particular, talking about results. Do we understand the source code at the top in the white part? With the things that I mentioned before, do we remember our friend IND array? An object like this. Okay, good. Equal. Oh, looks like I am not going to create an array. I am going to receive an array as a return value. Okay, a return value from where? From the neural net. From the neural net, yes, I have a method output. The method output is going to give me in an array what? I am going to send the input. I am going to send this one as a parameter, and I am going to receive back the results for this. And you can be thinking about this one, that input, in this case, is exactly the same for the training and for the testing. But you can imagine that that one could be a different set of input, a different set of data that you can use for testing your net, right? Here, only 4 rows. I am using the same for testing and for training. I am going to pass that to my network, and I am going to ask for the output. Now, what I need to do to compare the output with the real ones, right? I can do it manually. You have the source code for calculate the input, the output, the subtraction, square, MSE. Let's create an object. Evaluation is my object. My object evaluation is a method that have inside a method eval. And I can call eval from my object. Sorry if I put the same name to the method and to the object, but hopefully that doesn't make a problem. The object can be evaluation if you want. This is evaluation.eval. And I pass as a parameters the output, the one that I use get, and the noun output, that was the one that I read from my file. Did you notice that I am creating an object, and that object is here? The result from the neural net and the original ones. Do your work. You can think that the only work that my object here is going to do is the same thing that we did, the subtraction, square, and addition. That is too primitive. This new class and this new method is going to do something more fancy. It's going to calculate several different things. Moreover, it's going to calculate several different things that I am going to explain right now. And then I can use the object, call a method, and this method is like a toString method that is going to return a string with all the results of the evaluation. Method that returns a string, print that, and this is going to be my output. This is the evaluation of the neural net. And can you notice that it includes more than use the MSE value? We have an object, we can put several fancy things in the object, and we do not care about manually implementing things. Now, the output, can you help me? What is this? It's kind of ugly, but statistics, math. Are you familiar with this idea of true positive, false positive, false negative, true negative? Those two words make sense?
Yes.
Okay, and those guys are usually in this box, and that box, 2 columns, 2 rows, have a special name, fancy name.
Confusion.
This is your confusion matrix for the neural net. Don't worry, I am going to give you details, but just to let you know, this is important. This thing is important. It's giving you the performance of the net. Accuracy, precision, recall, F1 score. We are going to the details. I am going to give you this information because we are going to listen about that, but these words are important. Now, if you do not want to remember what is exactly the name of those words, the important thing here is having a 1 here or a number that is close to 1 is good. In fact, 1 is perfect. Our program, this program, is perfectly identifying the XOR operations. No errors at all. What you do not want to have is zeros here. Zeros is bad, or any number close to 0 is bad. But it's easy to remember, right? 1 is good, period. I need to explain you more details about this. I am going to do that, but this is very good. This positive number here, this main diagonal, zeros here, also is very good. These two results for the net that I give you is success. We have a perfect network. It's just 4 inputs, right? I am wondering, the one that you implement from scratch is also perfect like this? Why not? It's the same 10,000 iterations and so on, and the same equations.
We don't know if it's perfect or not. We need to evaluate that would be.
Yeah, I just ask about if you know that what's perfect or not. I didn't give you this kind of evaluation in the source code. Hopefully you can include something, but so far it is probable that you are going to get something that works similar to this one, just because it's, again, too simple. What is not going to happen, something like this, so perfect, is in the next example where we move forward from something with 4 inputs to something else. But again, this is perfect. Now, the details, just because we're going to use this with other methods, not only with neural networks. Details here, number 1, in the results, elements that we use to compare prediction versus the real world, the output that you know and the output that you get with any method is the confusion metric, the accuracy, the precision, and the F1 score. I am giving you definitions in this slide, but I am going to go step by step with them. One question before we start. F1 score, the harmonic mean of... Oh, okay, this one is connected with these two. Is the harmonic mean. Do we know what is this? Yes or no? I am going to show you, don't worry, but okay, makes sense to show you. Remember this fancy name, the harmonic. Okay, let's start one by one because I want you to remember these things to compare. Number 1, the confusion metric. That is our confusion metric. The confusion metric, that picture that looked horrible with just characters, is really representing something like this, more fancy. More fancy, and let me tell you, okay, quickly. 2 rows, 2 columns. The rows are going to tell you positive or negative. Positive or negative in our example is 0 or 1. Do you remember that what we have right now is that the output can be 0 or 1? And we have 0 or 1 for the value that we are expecting to have in one output, but also we have the 0 or 1, the value that is predicted. So can we visualize that the true value can be 0 or 1, but then the prediction is 0 or 1. So what we do here is, in this binary thing, to take a look, and it's like, okay, I am expecting a 0. Did I get the 0 or did I get the 1? I am expecting a 1. did I get the prediction of the 1 or did I get as a prediction of 0? Do you agree that if I am expecting a 0 and I get as a prediction a 0, this is kind of a happy moment because I get what I want. Also, if I am expecting a 1 and I get a 1, this is a happy moment because I get what I want. Now, if you are expecting a 0 and receive a 1, or expecting a 1 and receive a 0, these two parts here are kind of the sad part because you do not get what you want, what you are expecting, right? So that is the reason, because in the picture, these two are kind of the ones that you want to be positive. Moreover, these two are the ones that you want to have in 0 or close to 0, because it's these two, yes, the network guess. These two is, oops, the network failed. Doesn't matter what was the order. Makes sense. Confusion metric, because here with these happy faces and sad faces, we can calculate the other three values. However, I am going to stop here. We continue next lecture. Thank you.